Okay then, so quick reminder then of the structure of an atom. So in the center we have got our neutrons and protons, and our electrons orbit around the nucleus. So we can add on here that this midsection is called the nucleus, which is the nucleus that contains the protons and the neutrons, and the electrons orbit around the outside. So we can work out how many protons, neutrons, and electrons an atom has by looking at its chemical symbols.
You don't do that. Can you turn it off before I log on?
No, log on, and when you're done,
It caused feedback.
it doesn't matter.
Okay, just put yourself on mute, please, Lily. So when we look at the periodic table, you see these values that are associated with it. Okay, so carbon, for example, this top number, this is called the mass number. And this bottom number is the atomic or the proton number. Now this is on a small key on your periodic table. I will show you a periodic table in a couple of slides. So it's on the key on the periodic table. So if you forget that information, it is there for you. Remember, you do get a periodic table in your exam to use. Okay. Now, what these allow us to do is it allows us to work out how many protons, neutrons, and electrons it's got. Now, you might have been asked to sort of pen them. I know that's something that I use. So straight away, we already know how many protons that's got. Okay, so we'll come back to this in a moment. We've done a little bit more digging about what the atom looks like. So just a very brief history of the atom then. So we can see going back to sort of the 1800s, a chemist called John Dalton posed that the atom was a solid sphere. So you can see that it's like a billiard ball. So think of like a ball off a pool table or a snooker table. He thought that it was a solid mass. So that was the first idea that we had. And then in 1897, so that was, you know, that went for quite a while that these were these solid spheres. But in 1897, a gentleman called J.J. Thomson posed that there must be charges in it. Basically, what he did is he took two plates, one charge positive and one negative, and when he fired these atoms through, if there was no charge to them, if they were just these solid spheres, they should just shoot straight through and not get affected by these charged plates. However, when he fired when he fired these atoms through, he actually found that they were deviating, they were traveling towards the positive plate. So he realized that there must be some charge in there. And so therefore he discovered the electrons, but he thought that they were just still sort of a solid sphere with electrons dotted within them. Between about 1909 and 1911, it was Ernest Rutherford that brought together the model that this is what we usually see. We see a lot of things like if you watch The Big Bang Theory or anything like this, you'll see this kind of model. And he proposed that the electrons were orbiting that central nucleus. So we're getting more to what we know today. And then it was in 1913 that we got to the model where we are, pretty much where we are today, what we learn about in lessons, into the Bohr model, that these electrons are orbiting in these different energy levels. And that's where we pretty much are today. Excuse me, I've got an awful tickle. We have gone on further, getting really quite high level physics, a little bit too much for me even, about the quantum mechanical model. Okay, so that's just a brief history of how that model has changed over time. Okay, so one thing we need to know about them, we need to know the charge and the mass of of these different subatomic particles. So we know they're made of protons, neutrons, electrons. Now their charge, proton works quite well because a proton is positive, P and P. Neutrons are neutral or zero charge, and then electrons are negative charge. And their mass, proton has a mass of 1, neutron 1, and electron 0. So coming back to this that we were doing earlier, so just a quick reminder, protons, electrons, neutrons, remember this bottom number is the atomic of the proton number. So we know that there's 6. That means it must have 6 positive charges, and atoms are neutrally charged. So therefore it's going to have 6 negatives to balance that out. It's also got 6 electrons. And this top number, the mass number, tells us how many protons and neutrons, because these are the 2 particles that have mass. So we know that we've got 6 protons because we're looking at that bottom number. So if we do the 12 minus the 6, we know we've got 6 neutrons. So therefore we can work out how many protons, neutrons, and electrons there are. Okay. So I've just done that on the other slide, doesn't matter. Right, electron structure is a quick reminder of where these electrons go. So the first shell can hold 2 electrons, and we usually see them drawn opposite one another because they have the same charge, so they will repel one another. However, it doesn't matter. As long as you get the correct number on that shell, absolutely fine. Second shell can hold 8, and the third shell can hold 8. And we fill the inside shells first. So if we just very quickly whiz back to carbon, we know it's got 6 electrons by that bottom number. We've put 2 in the first shell, that's now full. So we need to then put the remaining 4 in that second shell. Okay, so 2 in the first, 8 in the second. If I'd filled that, if I was above 10 electrons, I'd then move into my third shell. Excuse me. Okay, just a little introduction then to the periodic table. We're going to focus more on this in another session, but the periodic table is a chemist's best friend. It tells you so much information. Okay, so a couple of key things that I'll remind you of. Hopefully you do already know these and it's just reminding you that across this division here, this is what separates our metals and our non-metals. And I remember that, where to put that division, I remember it as the aluminium steps. So it's above aluminium and it's that step in motion. So all across, whoops, I don't know what I was going to write then. This side of the periodic table are metals, and it's only this upper right corner that are non-metals. We've got on here these numbers at the top. These are the group numbers. Hopefully you know the names of some of these groups, but the group number tells you how many electrons are in the outside shell. Okay, that's another bit of information it gives you. Electrons in the outside shell. We can also number the rows. So we always number the rows from this side of the periodic table. So next to helium, we're going to put number 1, because even though there are no elements, this row does go all the way across. So it includes hydrogen. And again, it's all the way here, even though there's no elements in it. So we need to number it at this side. If we number them at this side, we're going to get them incorrect. So number 2, 3, we'll just go all the way to the bottom. And these are the period numbers, hence the name periodic table. So the columns are groups, the rows are periods. And the period tells you how many electrons, how many electron shells we have, sorry. Okay, so it's the number of shells. And if we just quickly look at one, let's go for, let's highlight it so you can see which one I'm looking at. If we go for, we'll go for nitrogen here. So let's just have a quick look. So nitrogen, numbers are 14 and 7. So electrons, it has 7. So we're looking at that bottom number. We've got 2 in the first shell. I've got to move into my next shell. I've got 2 already, so therefore I need 5 in here. So based on what I've just said, if the group number is the electrons in the outside shell, it should be in group 1, 2, 3, 4, 5, and it's got 2 shells, so it should be in period 2. Let's have a look. Group 5, period 2. Okay. Right, any questions, pop them in chat. What we'll do now is we'll start and look at some exam questions. So we'll do exactly the same as I did last week. I'll pick out the key parts of the questions. I'll give you a moment to have a go at answering them, and then I'll go through the answers with you. But please do, any questions at any point, please just pop them straight into chat. Okay, let's get you, if you've got a copy of the periodic table handy, brilliant. I will try and copy it into questions where you might need it. Okay, so remember, you get a copy of the periodic table in your exam. So looking at this, we're looking for the element that's got a mass of 9. And if you can't remember which is the mass number, use the key, and an element that has 9 protons. Okay, so you're looking for 2 separate ones because you've got 2 marks available. Okay, so I'll just give you a moment to have a go at that. Okay, hopefully you've managed to have a look at that. Please do, by the way, if I am going too quick or too slow, please do let me know. So the element with a mass of 9, so it's a nice straightforward question. Top number is relative atomic mass. So if you've forgotten, it's there in that key for you. So you're looking for which one has it, the top number of 9, and we're here. And I'll identify the other one before I write them and just stay changing my pen. And the element with 9 protons, so that bottom number, atomic proton number. So the number we're looking for 9 at the bottom is there. So the element with a mass of 9 is Be. It asks you for the chemical symbol in the question. However, if you had written beryllium, it would be absolutely fine. And the element with 9 protons is fluorine, so we just need an F. So 1 mark for each. Okay. So here we've got a series of diagrams around around what we discussed with the change. Can you just make sure you're on mute, please, guys? About that change. About that changing of the model. Okay, so they're not in the correct order. So you literally, for these, just 1 mark each, ticking 1 box. So just make sure you tick 1 box. If you need to change it in an exam, just make sure it's really obvious that you've crossed that one out and reticked, because if you tick 2, you won't score the mark. Okay, so just give you a couple of seconds to have a go at those. Okay, so the diagram that represents the plum pudding model. So this is where we discovered that there were electrons. So the negative electrons dotted throughout. So we've got 2 very similar diagrams here, but we're looking for the one with the negative. So it is B. Model that is represented on the alpha scattering. That was where we discovered that was actually space, empty space in that. So this is C. And the diagram that represents Bohr's work is A, closest to the model that we currently use today, the electrons in the shells orbiting the nucleus. Okay. Okay, so the second row of the periodic table holds 8 elements, starting with lithium and ending with neon. So we're going across the levels. So figure 2 shows an atom with 2 electron shells or energy levels. That word does get interchanged. Now let me just grab you. I'll chop it down so that it's not taking up, oh, wrong one, it's not taking up the whole of the thing for you. So you need to represent boron. So boron is over here. So if I, oh, get off. I chop this periodic table down for you, because we only need that section. Okay, that you should be able to see. So boron is there. So for part B, it just simply says name. So you just need to put the name of it, just 1 mark, and then 5C is give the name of the subatomic particles that are in part Z and their charges, and that's worth 3 marks. Okay, let's run through this one then. So it tells you roughly where it is, the second row of the periodic table. So you've found yourself boron. Complete the diagram to show the electronic structure. So they've given you the shells, you just need to pop the electrons in. So we've got 5 electrons, 2 on the inside. Remember, we fill the inside shells first. We've got 5, therefore we need 3 more. Now, as I said earlier, it doesn't matter where you put those electrons. The key thing is that you've got 2 on the first shell and 3 within the second shell. Name the part labelled Z, so we just literally need to write the word, nothing else. Is the nucleus. And then give the name and state the charge. So in part Z, we have the protons and the neutrons. And if you've indicated simply with a positive and a 0, or you've written the word positive and neutral, absolutely fine. Okay, so that one is worth 3 marks. You would get 1 for identifying the proton and the neutron, and then 1 for each of the charges. Okay, I'm going to keep it swift and keep moving. Okay, the electronic structure in figure 3 of neon is not correct. Explain what is wrong with the electronic structure. So if I grab you that piece of periodic table again, in case you can't see one. So neon is there. Just going to put here that there's 3 marks. So identify what is wrong, and then you need to explain. So identify it and say why it is wrong. Okay, there are 2 big errors there. So just give you a couple of minutes. Okay, so let's find ourselves in the periodic table. Neon, we're over here. So if we're looking at the bottom number that tells us the number of electrons, neon has 10 electrons. So the first thing, if we have a look, well, I can see straight away that I've got 8 electrons in that first shell. So that we know that that's incorrect. And then if we have a look, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons rather than 10. Okay, so your marks are available for saying the number of electrons is incorrect. You could have backed that up with that neon has 10, or if you said it is fluorine that has 9, or it's got 1 electron missing. I'm just going to say 1 electron missing. Yeah. And the second point is that the first shell can only hold 2. there are 8 in the diagram. Oops, I missed my eye. Okay. So 1, the number of electrons is correct. 2, is incorrect. Sorry. Number 2, the first shell can only hold 8, but it's got can only hold 2, but there's 8 in the diagram. And point number 3 is the second shell can hold 8. Okay, so the 8 should be in that second shell, not in that first shell. Okay, let me just quickly, I've just taken chat away. Good. Okay, next question. Really nice and straightforward, this one. Make sure you know these mass and charges because they're 4 marks for completing this very simple table. Okay, so we'll run through this one quickly. So proton has a mass of 1 and a charge. If you've written the word positive or put a plus sign, either is fine. Neutron is completed for us. Therefore, we've got proton and neutron. This one is our electron. Mass that is very small, sometimes it's put as 0, which is also fine. And we've got a charge of positive, neutral, neutron. Therefore, we must have a negative electron, and it's 1 mark per correct box. So this one, you have the actual structure, including the correct number of subatomic particles. So by using those subatomic particles, work out what the atomic number and the mass number of that unknown element is. So don't worry if you actually look at the periodic table and it's not there, it's not correct. You just need to work out which one it is. Okay, so atomic number is the number of protons. So we can see that we've got these positive charges, so we can count these up. 1, 2, 3, 4, 5. Okay, so that rules out it being row A or D. And the mass number is the number of protons plus the neutrons. So that's everything inside the nucleus. So we've got 5 protons if we count the black circles as well. 1, 2, 3, 4, 5, and 6. So it will be the 5 plus the 6. Okay, so 5 plus the 6 gives us 11, which means it would be row B. Okay, so we've got just a statement, a question about atomic structure. A group of students look at the diagram below showing the electrons in a chemical substance, and the students make the following, and these are either incorrect or incomplete conclusions. Okay, so we've got students 1, 2, and 3. So part A is to explain how student 1 and 2 could combine their ideas and produce one possible correct conclusion. So these two need combining. Okay, so have a read of them. What have we got? Fluorine, neon, or sodium. To grab you that little piece of periodic table again. Might just pop you that in. That might be useful. Squeeze in there for you. So we're getting into the higher level thinking questions now. Oh, put on the wrong one. My apologies. How could you combine statement 1 and 2 to make one correct statement? Okay, so explain how 1 and 2 could combine their ideas. So student 1 states that the substance is fluorine, neon, or sodium. Number of electrons: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Neon does have 10 electrons. Yeah, so we're partway there. Student 2 states that it's not possible to determine which atom or ion the diagram represents. Okay, so student 1 suggests, so explain how they could combine them, because student 1 suggests the elements. Oops. Yeah. Now student 2 talks about atoms, and it can only be neon because it's got 10 electrons. So student 1 has the correct suggestion, but student 2 then needs to go on and explain a little bit more detail that we can use the number of electrons to work out which atom it is. Oops. Okay, so they're both kind of onto something. They just need to further their answers. So based around the same diagram, part B is to evaluate student 1's suggestion of fluorine or sodium. So why has that student, why have they picked that it could be fluorine or sodium? Just highlight where those are for you. So fluorine, save copying it across, I'll give you sodium numbers 23 and 11. So if you're struggling slightly, think in terms of losing and gaining electrons. Okay, so it could be fluorine if it gained an electron. Okay, so it could be fluorine if it gained an electron. That would give you 1 mark because it's got 9, whereas we know this diagram has got 10. But if it picked an electron from a metal atom, it could be fluorine. And it could be sodium. Sodium has 11, but if it lost an electron. So it could be sodium if it lost an electron. And that's going a little bit further, and that's something that we'll dig into a bit more when we look at ions and ionic bonding. So it could be fluorine if it gained an electron for 1 mark, and it could be sodium if it had lost an electron, because without being able to see how many protons it's got, we're relying on the electron structure to tell us what it is. So we need something a bit further to define what it was. Okay, last couple of questions. This question is about chlorine. Explain the information given by the numbers. Okay, so there's 3 marks available. You'd say what the numbers are and what they are telling us. Okay, so 35.5, for example, what is that number and what does it tell you about it? Okay, so top number is the mass number. Oops, squeeze a little m in there. Number tells us protons plus neutrons. And we need to say that the bottom number, or if you said the smaller number, that is okay. So if you said the bigger number for the mass number, that's fine. Bottom number is the atomic number. And this tells us the number of protons. Okay, so 1 mark for identifying what they are, and then your second and your third mark come from explaining what they are. So they always want a little bit extra from you in the first point. me just check what this last question is. I might just swap this round while I grab you. Are we going to need a periodic table? Right, let me copy it across. I'm just worried. It might be a little bit small. Let's have a look. So relative atomic mass of 9. So if we just pop it there, I know I'm covering up part of the question, but you can see this. So which element has a relative atomic mass of 9? So find the element that has got a mass number of 9, and then you need to use the letters of A, B, C, D, E. So not using the symbols, find it on the periodic table, and then compare it to where it is on that figure 1, that simplified one. So element with a relative atomic mass of 9. Oh, might be able to just squeeze it there for you. So they're all worth 1 mark. Which element has got a complete outer shell of electrons? And which element has 1 electron in its outside shell? Okay, so part A, atomic mass. Remember, top number is the atomic mass. Looking for one with 9 is here, beryllium. So this would relate to B on your periodic table. With a full outer shell of electrons. So it's, remember, the group number tells you how many electrons in the outside shell. And this is group 0, group 8. So the one in here is E. And the last one, the one that's got 1 electron in its outside shell, we're looking for something in group 1. So here we've got sodium, which is A. So we've got E, B, and A. Okay, I'll copy that again. So last 2 questions, put that down there for you. So you're given the elements. Yeah, I'll go back and explain it in a second. You're given the electron structure. So when we write them, this is telling us who element W, for example, has 2 electrons in the first shell, 8 electrons in the second shell, and 1 in the third. So you can either add them up and look for the bottom number, or you know it's got 3 shells, so it'd be in period 3, and 1 electron in the outside shell, so it'd be in group 1. Try and identify those elements. And then part C, explain why Y is unreactive. I'll go back to the next question in a second. Okay, so element W, 2, 8, and 1. So as I said, you could either add them up. So 10, it's got 11 electrons. So we're looking for number 11 on the bottom. So it will be sodium. But we also know that it must be in period 3 because there's 3 shells, or it's in group 1 because it's got 1 electron in its outside shell. So this would be sodium. So again, if I'm adding up electrons, 10, 18 electrons, so bottom number of 18 is here. So this would be argon, or again, I know it's in period 3. So we've got 3 shells and group 8. So I can also locate it that way. And then Z, 10 electrons, 18, 19. So we're actually over here in potassium. And again, backing it up by the fact that it must be in group 1, because it's got 1 electron in its outside shell, 4 shells, so it's in period 4. Here it is. So explain why element Y is unreactive. Okay, so this is argon. If you know about these are the noble gases. And the reason it's unreactive is because it has a full shell of outer electrons, or the outside shell is full, however you've worded it. Okay, because it's got a full shell of outer electrons, and therefore it doesn't need to gain any, and so it's stable as it is. Okay, I'm going to leave that there because I've just a couple of questions that I will answer that have been asked. If you're happy, if you've no further questions, you are more than welcome to leave now. Thanks for joining in. Hopefully I'll see you next week. Right, just going to go back to this one then. In fact, I'll just stop recording.